Welcome back. In this series of lessons, we are going to discuss the proofs for the Euclidean geometry theorems. Remember, in every question paper, in every examination, there's one question about proofs. Okay, so there are 7 proofs that you have to know. You know all of them, and then in the exam you should be able to answer the one that you're asked to prove. So it is very important that you know all the theorems that are examinable. These are the theorems that are examinable. You can pause the video here and just check them. So these are the theorems you have to know how to prove. But in this lesson, we're going to prove the theorem which says that the line drawn from the center of a circle perpendicular to a chord bisects the chord. Right, so we are given a circle with center O, and then we're given that OM is perpendicular to PQ. Right, for every theorem, there are 2 main things you have to remember. You have to remember the theorems that are used to prove this particular theorem. 1, you have to remember your constructions. Actually, without constructions, you won't get the marks. So the first thing to do is to do your construction. Right, for this theorem, we have to remember congruency of triangles. So we have to construct these triangles by doing what? By constructing OP and OQ. See that? So we have constructed 2 triangles, which is triangle PMO and triangle QMO. Right? So remember construction, construct OP and OQ. Remember, these letters may change. You can be having B and A there. It can be any letter that is used there. Right? So we've constructed these 2 triangles, PMO and triangle QMO. So we have to prove that these 2 triangles are congruent. And then once we prove that these 2 triangles are congruent, we'll manage to prove that PM is equal to MQ. So we're talking about triangle PMO and triangle QMO. Right, let's start with these triangles. So we have OP and OQ. So we have OP is equal to OQ. And then why? Because these are radii. And then we have OM, which is a common side for these 2 triangles. So you can say OM is equal to OM because it's a common side. And then we have this angle, which is 90 degrees, meaning that this angle is also 90 degrees. So we have angle PMO being equal to angle QMO. They are both equal to 90 degrees. And the reason we're given. Okay, so if we check, we have the side OP and OQ. We have OM, which is a common side, and then we have a right angle there. So we can conclude and say, therefore, triangle PMO. You have to be careful. P goes with Q, M goes with M there, and then also this angle will go with this angle. Right, so triangle PMO is congruent to triangle QMO. And then the reason, you can say right angle hypotenuse side. So now from this we can see that PM is equal to QM. Remember, from congruency, PM is equal to QM, MO is equal to MO, then PO is equal to QO, like that. So here we're talking about PM and QM. So you can say, therefore, PM is equal to QM. And then the reason is congruence. You can write this statement as it is, because triangle PMO is congruent to triangle QMO. Okay, therefore we have proved that PM is equal to QM, right? And then it says that a line drawn from the center of the circle perpendicular to the chord will bisect the chords. You see that? So this line OM cuts the chord PQ into 2 equal parts, PM and MQ. Remember the reason for this theorem. We say line from center perpendicular to chord.